The Corps of Engineers. Engineers must be oriented and adapted to a multitude of tasks.
The Army Corps of Engineers is raising the dam by 8 meters.
U.S. Army Corps of Engineers.
The U.S. Army Corps of Engineers lays out their response plan.
We provide infrastructure assessment, temporary roofing, temporary emergency power. We help with debris assessment and removal operations. We also work with temporary housing.
And he'll tell you there's no end to the types of services the engineers provide.
Hello, everyone, and welcome to the Building Strong Buffalo podcast. This is the place to get to know the U.S. Army Corps of Engineers Buffalo District, our people, and our stories. My name is Jess Levenson, your host and public affairs specialist with the district. This week is Engineers Week, so we're calling attention to our awesome engineers carrying on a tradition of making the world a better place. Engineering is behind nearly everything that makes our lives easy and enjoyable. Cell phones, engineers, makeup and cosmetics, also down to engineers. Clocks, cars, computers, cutlery, compasses, contacts, calculators, cameras, cans and can openers. It's all down to engineers. Today's guests are Katie Lewis, civil engineer, Mary Samoi, electrical engineer, Cedric Grobel, geotechnical engineer, Lauren Schifferle, hydraulic engineer, who will be coming on later in the podcast, and finally, First Lieutenant Stacey Acapana, mechanical engineer. So let's jump right into it. Good morning, everyone. It's so nice to see you all. It's been way too long since we've all been together under one roof. Yet engineering allows us to do what was impossible just a few decades ago and interact like this. And I know it's been a long time since we've seen each other, but actually the person I've most recently seen in person is First Lieutenant Stacey Acapana. We were in Cleveland together just about a week and a half ago. And I want to also give a warm welcome to her because I believe you just got onboarded about a month ago, right?
Yes, I did a little over a month ago. Came into Buffalo and been just trying to get on my feet here in the cold weather.
Yeah, it's been snowing quite a bit since you got here, but big flakes, so fun times if you want to go sledding or skiing or anything. So we're going to do a round of icebreakers so our listeners can recognize, everyone's voice and so that all of you can loosen up a bit. So we're going to do what's your full name, what's your alma mater, and if your field of engineering had a dance move, what would it be called? I'll go first to break things up. My name is Jess Levenson. My alma mater is the University of Massachusetts Amherst, and I majored in communication. And my dance move would be called Talk with Your Hips. So we'll start with Katie.
Okay, so I'm next. So my name is Katie Lewis. My alma mater is Widener University, just right outside of Philadelphia, Pennsylvania. And my field of engineering is civil engineering. And I guess if I had to say a dance move, we like to build things, so let's call it the builder.
Would that be kind of like with your arms, with your legs, whole body, like what style?
You know what? We can just start from the bottom and work it up with the music,
I love it. That's building it, yeah. All right, so next up we have Mary.
Hi, my name is Mary Samoi. My alma mater is University at Buffalo. I did electrical engineering, specialty in power systems. And my dance move will be ballet.
Nice. Why did you choose ballet?
I feel like in engineering, you have to master or have a strong foundation before you start working on hard and fun stuff. So that's why I chose ballet.
And next up is Cedric.
Hi everybody, my name is Cedric Grobel. I am a geotechnical engineer with the Coastal Geotechnical Engineering team, and my alma mater is the University of Buffalo, where I studied structural engineering and specialized in advanced materials. And my dance move is going to be the moonwalk, because nothing is better than the moonwalk.
As you can hear, Cedric is cheating because he's on a rolling chair, so of course he can moon anything. And last up, we'll go with Stacey.
Hello, Lieutenant Stacey Acapana. I went to Villanova University. It's in Villanova, Pennsylvania, outside of Philadelphia, pretty much. And for the dance move, I chose, I called it the dynamic step, just because in mechanical engineering you study a lot of dynamics and vibrations. So I felt, it was just fitting.
All right, thank you so much, everyone, for playing along with me with that. And we'll jump right into the question section of this podcast. And we're going to do a little bit of a backward style question here. I'm going to ask you first off, because Katie is first, how would you describe a civil engineer? And that question can mean anything from what does your stereotypical civil engineer look like, it sound like, or think like, what pops into your head if someone asks you, how would you describe a civil engineer? We're going to start backwards order. So it'll go Stacey, Cedric, Mary, and then Katie will jump in at the end and say, all right, guys, that was fun, but let me tell you how it really is and kind of explain what a civil engineer is really like. So let's start it off with Stacey. How would you describe a civil engineer?
For civil engineers, what comes to mind for me is pretty much horizontal, vertical engineering, and think a lot about the concrete, and they talk about like some tests and all that, so that's kind of what comes to mind immediately.
Ooh, well, let's see. Civil engineer. So I agree with Stacey, horizontal, vertical construction. I think mixed in there, you have a lot of dealing with contractors, quality assurance, submittals, change orders, and solving on-the-job problems at the site.
For me, when I think of civil engineers, I think of bridges, and I see them reading these big books, Bibles or something. So when I just think of civil engineers, I think of bridges and tall buildings.
Well, I'll talk about civil engineering. So I think a lot of people's misconceptions is that civil engineering is mainly construction. But when I was in school, there was a few different disciplines that you could go into as a civil engineer. So you have your construction management, you have your structural engineers that fall under civil. You could go to your geotechnical, which, builds the foundations for all these wonderful things you see above ground. There's also water resources. And then transportation is actually under civil too, which is why I chose civil engineering. It was kind of the most diverse. And when I went into college, I wasn't exactly sure which discipline I wanted to study in. So as far as what civil engineers do, I would say we cater to what the public needs, whether it's roads, bridges, buildings, wastewater treatment plants. Civil engineers help make the society work. And definitely combine with a lot of other engineering disciplines to make that possible. But yeah, it's we're not building, we're also doing maintenance, and we're inspecting to make sure everything's still safe for people to use those public buildings or roads or whatever. So as far as the type of civil engineer, because we're so diverse, I don't think there's one type of mold for engineering anymore. I think the old train of thought was maybe, the number crunchers and people that were a little nerdier and just wanted to keep their head down. But there's so many different things you can do now, and technology allows anyone to keep moving forward. So for me, I'm not necessarily a numbers cruncher type of person, but with what I do in construction management, I really love organization, keeping things together, when you're looking at a contract. And I love the interaction. You still need good communication, whether you're in engineering or not, just to make sure everyone understands what the project's doing, where things are going. So in that aspect, I don't think I quite fit the mold of that number crunchers engineer, but yeah, that's what I think civil engineers are to me.
Okay, thanks, Katie. That was awesome. Really appreciate you talking more about what being a civil engineer is like and how you see things. So we're gonna start talking about how would you describe an electrical engineer now. And that order is going to go Stacey, Cedric, Katie. And let's get creative. Let's be, what do they sound like? What do they look like? What are their idiosyncrasies? And then Mary will say, what are you talking about at the end? So take it away.
Let's see, for electrical engineering, I only took a few of these classes in undergrad, and it's definitely something different. You don't see your work. It's like abstract. And they work with like breadboards, and I just thought it was weird to work with bread.
And from the electrical engineering classes I took in undergrad, there were, logic diagrams, circuit diagrams, and a bit of calculus from what I remember.
For me, I always hated just looking at all the lines and circles that would make up electrical diagrams, and I always thought it took a talent for electrical engineers to read all of them. And I know this isn't what electrical engineers do, but I had an uncle that always worked as an electrician, and they were always a little, I don't like working with electricity, so, people that work with it always amazes me.
What are you guys talking about? Maybe I'll tell you what electrical engineer does. I think I'll describe an electrical engineer as someone who uses technology to play a major role in, it can be saving the environment or modernizing the civilization through innovative appliances. You have a lot of appliances in your house. You have electronics, you have your phone, the telecommunication system, you have energy production. You see these power stations. And we also have signals and systems that goes to telecommunication, I guess. And when I was going through college, I chose a power system. That's because when I was growing up, I had the belief that electrical engineers do provide us with electricity at home. But when I go to college, they're just electrical engineers. They can do a bunch of different fields. You can specialize in different fields like telecommunication, like power system, electronics, all that.
Thanks, Mary. Yeah, it's really interesting how, like, someone who's not an engineer like me, I think, there's so many categories of engineers, and then you're saying you can get even more specific into power systems or telecommunications. All right, we're going to move on to Cedric and being a geotechnical engineer. So how would you describe being a geotechnical engineer, or your impressions of them? Stacey, Mary, and Katie.
So for geotechnical engineers, I immediately just think of soil and I guess trying to investigate the soil and learn about it.
When I think of geotechnical engineers, I just see them monitoring structures, like tall buildings and all that.
Well, I started out in geotech before construction management. So for me, I automatically think of logging borings, logging soil, rock analysis. So I love that. And that's what I think of geotech.
Yes, all great descriptions. And I'll say that Stacey had it right when she said soil, because a lot of people like to say moving dirt, and that is one of our mottos here. Geotechnical engineers do a lot of soil analysis, but there's more to it than that. You also have Geophysical Services, which is a new domain of the geotechnical engineering realm, where we use where we pass current through soil, we use sound, and we measure, or we can map things underneath the subsurface without the traditional destructive testings, which a lot of people associate with geotechnical engineers like myself. What do? We drill, we blast rock, we core rock. Well, now we can get away without doing that, and we can also preserve the environment in a meaningful way through those methods. And also geotechnical engineers, like Katie had said, monitor foundations. We monitor dams. We monitor the flow of groundwater. If you have a well in your house, maybe your house has well water. That's what we do. And it's part of what Lauren does as well.
Thanks, everyone. We're now on to the final kind of engineer, mechanical engineer. Hit it away, Cedric, Mary, and Katie.
Mechanical engineers, in my opinion, bring everything together. You're using, underneath that umbrella, you have a little bit of electric, you have a little bit of structural, you have a little bit of material science, and they do really cool things with physics and dynamics and moving things in parts.
I would agree with Cedric. When I think of mechanical engineers, they bring all these small parts together, and like in a vehicle, that's the first thing I think about mechanical engineers. They just put all these small things together and they move.
I guess mechanical, I know, has so many different disciplines, just like all of our engineering fields, but the first thing I think of when I hear mechanical is always going towards robotics. And you know, lately there's always advancements in that area as well.
So I definitely agree with pretty much everything all of you said. Material science, cars, and robotics, definitely part of mechanical engineering. Heating and cooling systems like refrigeration, the elevator, thanks to robotics, thanks to mechanical engineering and its technologies. So pretty much encompasses, like you said, a little bit of most of the engineering disciplines, and pretty much why I was drawn to it.
Nice. Yeah, as a jack of all trades myself, I like to consider myself mechanical. Sounds pretty cool. And it was really interesting to hear how all of you talked about how your engineering discipline not only involves the finished product, you know, the thing that's in reality that you can interact with, but that you use numbers so often, and you, especially electrical engineers, they're kind of just looking at a diagram to figure everything out. But it's all coming to be based for people to interact with this thing in the physical world. It's really interesting. All right, the next question is, what makes your engineering discipline special? What makes a civil engineer special? What makes a mechanical engineer special? What about what you do kind of influences your uniqueness in the engineering universe?
Okay, I'll go first. For civil engineers, I think the reason why it's so special is because everyone uses it every day. And I think a lot of people don't realize the effects civil engineering has on a society. They don't think about how the road was built. They just drive it. They don't think about the house. They just live in it. Same with wastewater treatment. You know, everyone loves indoor plumbing, but they don't understand that someone had to engineer that. Someone has to maintain that. So I think that's kind of why it's special, because it touches everyone.
I think what make electrical engineering special is that their work is essential in everyday life. You see the household appliances, and you see them in the kitchen, everywhere in your household, the lighting, the buildings, telecommunication, your phones, your computers, those are being used by essential workers. and to even big power generators you see in the power stations that provide us with electricity. So you see it in everyday life.
What I think is special about geotechnical engineering is the unseen nature of our work. People take advantage of, or people don't take it for granted that there are these large buildings next to rivers and next to large bodies of water. That requires intervention. These large, tall buildings, like the CN Tower or the Burj Khalifa, these all required subsurface modification to make these high rises possible. And another completely unrelated field from that to the uninformed observer would just be flood protection systems, levees. Think in New Orleans. Think about all these cities and towns along the Mississippi River. Without geotechnical engineers, these towns would regularly flood as the river level drops and rises with seasonal changes. So the geotechnical engineer plays a large role in flood mitigation and in structural design.
For mechanical engineering, I think what makes it special is that, as well, it's daily use. The internal combustion engine kind of changed the world, being used in the cars. That's something that's pretty much used by everyone daily, even if it's just go to the grocery store, go to the gym. We're virtual right now, but usually to go to work. As well as the heating and cooling systems. We wouldn't be able to stay warm in our houses, without having the technology that came about through mechanical engineering. We wouldn't be able to keep our food cold in the fridge. So I think these are great things from mechanical engineering that we use daily and makes it so special in our lives.
Something that pops out to me that we'll also touch on in a later question, but it goes to the responsibility of an engineer and kind of what it's all about. And what I'm hearing is that an everyday person is now able to really get their lives changed and live a better life because of the work that all of you do and bringing it together for solutions. Mary said technology is now accessible. Katie said people can use roads. It's not just only a select few people who can afford to use these things. What do you guys think about that?
And Jess, I think that common theme was we affect everyone in society, but I'm not sure everyone fully understands or appreciates, where engineers from the past have brought society. It's what we have now is just second nature. You go to the fridge, it's there. But, back in the day, someone had to invent that, create that, build that. And it got adapted into society. So it's kind of how we live now has been changed so drastically because of engineering.
Right, living in these, going off of what Katie said, they're living in these nice vacation areas wouldn't be possible. Island living, New Orleans living, certain parts of Texas down by Galveston, living in these nice, pristine areas would not be possible without all the engineering disciplines, engineering solutions to allow habitation possible. Your house required a little bit of input from every discipline on this call right now, plus more.
And to go off of that, Cedric, just think about back in the day, everyone usually built near rivers and water. Now people go so inland because of engineering and sewer and pipe design and all that stuff as well. So it's been allowing us to advance and move out in our society.
Yeah, it's certainly neat too, quite a few people take for granted that their basement doesn't flood, but that's part of geotechnical engineering, part of civil engineering. You're going in there and you're choosing where to build a house based on the site conditions, and so you don't encounter wet basements, flooded homes, things like that. And like you were saying, Katie, we don't have towns centered around bodies of water anymore because civil engineering, geotechnical engineering, electrical engineering, mechanical engineering allowed us to live farther away from those natural resources and still supply us access to them.
And on the topic of all of those fields of engineering that are helping living around bodies of water, we have our hydraulic engineer, Lauren Schifferle. She's joined the podcast. Welcome, Lauren.
Thank you, Jess.
So what we're going to do is we're going to ask you the two questions that we've previously went over real quick and get you up to speed, as well as the icebreaker, because I definitely want to get you the icebreaker. So Lauren, just say your full name, your alma mater, and if your field of engineering had a dance move, what would it be called?
So, I'm Lauren Schifferle. I graduated from the University at Buffalo, and if hydraulic engineering had a dance move, it would be called Water Flows Downhill.
I love it.
Very energetic. We'd be diving on the floor.
Mm-hmm. Perfect. So, we're going to ask you to describe a hydraulic engineer. What does your stereotypical hydraulic engineer look like, sound like, think like, and what's your experience?
All right. So, my experience, your stereotypical hydraulic engineer is, well, they could look like anybody. And you're going to see as a hydraulic engineer is suddenly you start seeing water everywhere. You start paying attention to the weather reports. Before I was in this job, I read the weather never. And now I'm tuned into what the weather's going to be doing every day because all the people who are in the area that I work with are going to be affected by the weather, by the rainfall, by the patterns of weather and climate that are coming through. So now I see water everywhere. I watch it, and tying into what Cedric said, I just see water in every building. So I'm thinking about water intrusion and where it's going and where it's flowing all the time. I just see water everywhere.
So when you have like water cooler talk and small talk about the weather, it's not just small talk to you. It's like, oh my God, I love talking about the weather. It's so exciting.
There's also the component of like weather. It's happening and we can adapt to it, but we can't stop it. It's coming. And we have all these things at our disposal, all these different tools to help us work with the weather. We can build some infrastructure. There could be some zoning policies. There could be all these different ways of adapting to water, lack of water, and it's just, I see it in everything.
And the follow-up question is there anything else that makes a hydraulic engineer special besides this mind frame of weather and water stuff?
Honestly, that's an interesting question, Jess, and I might have a little bit of a different take. But I think that what I like about hydraulic engineering is part of engineering in general, and it's just the mindset. So it can be anybody, but it's having a rigorous process to evaluate things to make sure that that when we're looking at the weather, we're looking at the water, it's all about the process. So it could be anybody. It's just what makes a hydraulic engineer special is saying, I'm going to look into that. I'm going to look into water and what it's doing.
Yeah, it takes such a multi-step, years of training to like really get your level of thinking to a place where you can design things that are for the public good.
Yep, it's all public good field, and it does take a long time to develop the process and the habits and the mindset to get into an efficient method for looking at things and having that frame. But I truly believe it's all about what you want to do. So I think that anybody, all of you, can also be a hydraulic engineer. Come over to the wet side.
I love that. That's a great catchphrase. All right, so we're gonna get a little more personal on this next question, and again, we're not gonna do it in order, so feel free to jump in. But what made you first think of wanting to be an engineer? And you can talk about why you wanted to be an engineer in general, or why you chose your specific field, how you got into it. I'm really curious to know.
I guess I'll take a stab at this one, Jess. So I'm a builder, I'm a fixer, I'm an inventor. I'll fix something 4 or 5 times over before I throw it away and buy something else. I was raised that way. I'm a 3rd generation general contractor. I grew up repairing and flipping homes with my father, and I also grew up around large industrial machinery, as some of my family members worked in that field. So growing up is this learning the mechanics trade, learning the electrician's trade, learning the general contractor's framers trade, plumbing, HVAC. I wanted to get a degree that allowed me to understand why building codes were the way they were. I wanted to understand why I was taught to construct things the way I was. And so that naturally, I wanted to find an engineering discipline that would kind of bring all those together. So that's why I went to the University of Buffalo for civil engineering in particular. And my engineering discipline in specific, geotechnical engineering, I decided to pursue that right out of college, as there's a lot of room for advancement, and I specifically wanted a career that would allow me to contribute to a field. And so naturally, I was offered the opportunity, and I took it to be here with the Corps and engineer solutions to the nation's toughest challenges.
I'll go next. So for me, civil engineering, I do not come from a family of engineers. And when I was in school, I did gravitate more towards the math and sciences. And I just remember in middle school, we had this kind of an engineering club, and it was based off SimCity back when we were younger, and it really opened my eyes to different types of engineering. And then as I went to high school, my high school was fortunate enough to have electives that you could choose, and I had chosen CAD 1 and 2, and then technology information. And I still liked it. I still liked what I was seeing. I still liked seeing the innovations in society. And then as I kind of honed in on a discipline for college, I went civil mainly because it was what I thought at the time was the most diverse. So I kind of went that way, definitely was pushed to keep going as a female in a STEM-related field. Again, there's still not a lot of females in engineering fields. And then as in college, I jumped on the co-op track with my university. I did a 4-month co-op in site development, which I liked, and I liked with that firm, the company working with different companies to create one project. And then my second co-op was with Geotechnical, and again, I loved the field work. I loved the soil testing. So after college, I decided I was going to go Geotechnical. But with the Corps, I realized I wasn't getting out enough. And I realized my strong suit really was communication, relaying the engineering dialogue to other people. I missed interacting with other companies because with the Corps, we're such a big entity. We tend to work with the different disciplines within our own organization. So I had jumped to construction management, and I think I really found my calling, and I feel grateful that I was able to do those little changes even within my one discipline of civil engineering.
For me, when I was about 10 years old, my dad came home with a solar panel. And that alone was just amazing to see a solar panel in my village. That was the only solar panel. And we used that solar panel to power our black and white television. So as a small girl who grew up with no electricity all her life, I helped my dad set it up, and the next evening we were watching our television powered by solar. So that obviously developed my curiosity about electrical engineering. So when I got an opportunity to go to college, I knew that's what I wanted to do. I knew as an electrical engineer, in a small village like where I grew up, that alone, being an electrical engineer, just providing electricity to people, that can bring a big difference in people's life in developing countries. So in Corps of Engineers, I get to work in different projects and different with different disciplines, and I get to solve problems at work that just makes people's life easier. So that's the fun part of engineering, is just being part of that group or team that helps people.
Mary, where did you grow up?
I grew up in Kenya. It's a small village in Kenya.
Wow. Well, I'll go next. And Mary, that was a really powerful narrative. So I enjoyed listening to that. Thank you. Now it's harder for me to go after. So for me, coming to engineering was what I saw when I was little. My dad worked for Motorola. All his friends worked for Motorola. They were all engineers. So that was something that was mentally really available to me of engineering. And when it came time to pick something to study, I always liked asking, what would happen if? What happens if we do this? What happens if we do that? And trying to understand it and just kind of being super curious. And then I chose environmental engineering and water resources because I really wanted to improve the environment that was around us. Not just for ecology and for human health. And I think it was accessible to me because all of my family, or much of my family, is blue collar. There's contractors, concrete, my dad, and unfortunately my mother was a hairdresser, and I did not inherit any sort of affinity or skill in the hairdressing or aesthetics realm. So engineer was.
So for myself, I think what brought me to engineering was also somewhat kind of like Mary. My father kind of had to do with it. He had a small manufacturing company when I was younger, and growing up around a plant, CNC machines, and like designs, like CAD designs and such, kind of drew me towards it, and I wanted to learn how these designs come about and how I can be involved. I actually used to just draw Mickey Mouse faces on the AutoCAD for fun, just to play around with it. So when I grew older in high school, I definitely was into science and math. And so I just knew engineering was definitely what I had to choose. For mechanical engineering, I think I chose mechanical because, for me, it seemed broad and basically to encompass the design as well as building products. When it comes to designing and putting them into AutoCAD using the CNC machines. So pretty much that's how I went for it, and I've enjoyed it ever since. So I'm glad that I chose mechanical engineering and that I was able to figure out AutoCAD finally.
Thanks for sharing, everyone. All right, everyone, so we talked about what you all do and where you started. And my next question is, what's your favorite marvel of engineering? Large or small, it could be, I use my phone every day, like that kind of thing. Or something that changed the world in this really unique, eventful way. Like mine is the Large Hadron Collider. And it's because I love how it's like an enormous machine that is so powerful, and it's like 17 miles of tube or something, and all it does is it takes the tiniest particles imaginable and shoots them. So it's like this huge event, a huge space around it, but what you're observing and what you're kind of engineering is like the tiniest particles of the universe. So I just wanted to share that, and I open the floor to everyone again to answer, what's your favorite marvel of engineering?
One of my favorite marvel of engineering that I'm yet to visit is Amazon Fulfillment Center. I'm just amazed to see how they extensively use robots to increase efficiency in delivering their goods and services. So this is just a perfect example of how robots are going to change our future as far as work and business is concerned.
Well, so for me, I just get enamored with all the different types of bridges and buildings, and I don't really have a favorite, but I know my family thinks I'm very nerdy because whenever we're, say, driving on a bridge, I'm always like, this is so cool, look at this, and suspension, or it's not. And then from my background, I'm always like, man, this the foundation for this must be huge, and to build it. And my family, because they're not very big in the engineering field, just kind of roll their eyes. But I will say, you ask these questions, and over the weekend I actually watched Modern Marvels, and the Parthenon, for something that is so old and still stands, I mean, I could watch that show all day. It's just the engineering that went into that, the optic illusions, constructing that without all the gadgets that we have today. Stuff like that historically also really gets me.
Yeah, even something like the pyramids, they're still like, we really still have no idea how they built that without modern technology.
I mean, this question is so loaded because I have marvels from ancient times because I'm in just awe of how it was constructed, and how they got the materials to certain places. And then I have more modern marvels just because of where other engineers have been taking technology so far. So there's just so many options to choose from.
So if I'm going to pick one big thing, it would be the Haber process, which let us make ammonia fertilizer. And the reason for that is it freed up so much human capacity to be able to do all of these other things. By having better agricultural outputs, like now look at us, like we can specialize in all of these fields because we don't have to have everybody being farming for themselves. And it just lets there be such an explosion of like creativity and investigation. Honestly though, I think anything can be interesting if you just start looking at it closely enough and just keep asking like how and why, and assuming that when somebody's doing something differently that you have something to learn from them and they might have a different reason or motivation, instead of assuming they're doing it weird or wrong. Literally anything can be interesting if you just keep looking at it.
Yeah, Lauren, sorry, to follow up with that, it really resonated with me. Like, anything can be interesting. And again, watching TV last night, there's a show called The Food That Made America, and it went into just how the Reese Cup was built, was made, and all the engineering that guy did to put. And it's just, you wouldn't even think about the engineering that goes into food products. So even when you say something, it just resonates with me on just something I just watched on TV again. So that should be a lesson for everyone. Just keep asking questions, and the answers are pretty amazing.
And Kathleen, you mentioned how you get to tell your family all about bridges and bridge design when you pass them, and that's what I like in when other people have that knowledge about bridges, and then when you're going out with somebody and they're like, "Let me tell you all about this bridge," I want to see if we can, get on some sort of trip together or go out on lunch, and you can tell me about the bridges in your work, because I just love when people share their knowledge.
And going off of that is, in my opinion, what makes an engineer, and certainly a good engineer, is one that, without thinking too hard, can visualize, conceptualize in their mind on the fly what is going on with something. A bridge. When somebody without an engineering background looks at a bridge, they see a bridge. What do we see? We see forces, we see stresses, we see materials, we see how they ran the wires for the street lights. What is their vibration dampening system like? How is a car going to induce dynamic oscillation on this bridge, or dynamic vibration? What sort of material is the bridge built with? What is the condition of the material? That is an engineer. And it's a blessing and a curse, because the people around you got to hear you say, "Oh, look at that, it's falling. Oh man, that is some class A rust right there,"
So for me, a marvel that I picked was actually the Panama Canal. I read about it in the history books, so just learning about it was kind of amazing. And I actually got to go and see the canal for itself, and it was incredible, because it's just hard to imagine that all this work was put in, and they connected two different oceans. Now the world is more connected, kind of like we were saying before. Now we're able to connect the Atlantic, Pacific, and we don't have to go around the South America. So that was incredible to see. I also saw that they were expanding the loft at that point. That was a bunch of years ago. So it was great to know that they even expanded so that bigger ships can pass and more capacity.
Now, Stacey, I'm going to ask if you know an interesting fact about that project and how it relates to the Corps of Engineers.
Well, yeah, of course. I know the Corps of Engineers was working there. I actually stayed at the barracks where, pretty much the U.S. Army was staying at, and that was actually a nice experience being there. And actually, the Corps of Engineers is what built those barracks. So it was, great knowing that. And I didn't know I would be coming to work here at that time. I was still in college, but it's pretty cool to go around and now be like, oh, I've been somewhere where the Corps of Engineers has worked.
Yeah, I love all of your answers, and it's a great segue from what Lauren said of how, anything can be interesting. And my last question, which I'm going to kind of group for a larger question, is, can anything be engineered? Can love be engineered? can friendship be engineered? We talked about food, like can flavors of food be engineered? And then really there's a lot of dystopian, fiction out there that's becoming reality of like, can we edit genes? Can we edit people's, what makes them who they are, and engineer what a person is? And the question that I want to relate that to end it off is, what is your responsibility as an engineer to society and into humanity?
That is an interesting question. I don't know if anyone wants to go first. For me, you asked the question, can anything be engineered? And I think anything is possible. It's just, in what time frame are we at? If you ask that question in the early 1900s, I'm sure the idea of, or the 1800s, space travel probably wasn't even an option, but it is. So I do think anything can be engineered, but you definitely, when I was thinking about the question, you definitely threw me for a loop when you said engineered love and engineered friendships, which are very more emotional thoughts for my engineering brain here. I think of the real, stuff you can actually touch, I guess. Lately, I guess when you say engineering love, we have all these websites now that bring people together. That was engineered. I met my husband through one of those websites. So if you think about it in that sense of bringing people together with common interests and whatnot, I guess that would be a yes. And then I think the question for engineers in the future is, when you talk about engineering DNA and this and that, I think there's good and bad, and just we'll have to see where technology takes us in the future.
I think maybe in theory anything can be engineered, but in reality there are limitations that will take some time for technology to overcome those limitations. But talking of genetically modifications, we just heard of more than 700 million genetically modified insects being sent to Florida to kill mosquitoes that carry diseases like Zika virus. So if that's gonna be successful, that might be the road to getting a lot of things engineered.
Yeah, and just to relate to that specific example of what was it, genetically modifying, some sort of animal you said?
Insects?
Yeah, so insects, and then I know there's, GMOs, genetically modified, I forget, does anyone know, what does GMO stand for? Organism. So that's in a lot of food, and there's good and bad with that, because I know people have talked about that can solve world hunger. You can create giant pumpkins and giant tomatoes, but then at what cost? What effect does that have on human beings? So I just want to throw that in there before opening it back up.
There's so much to talk about here. So, really, to me, engineering is curiosity and having a process to know exactly how what you're doing, the effects of what you're doing are. And I'm going to take some of the harder questions you started with, Jess, which is can you engineer love? So then obviously you raised some good questions for me, but I think it's easy to see, somebody improving, their family's house as an expression of love. And I think it's easy to see somebody baking something as an expression of love. And then to take it a step further, is working on improving the building code for your municipality, or an expression of love for your community, possibly. Is somebody using the engineering process to really refine their recipes for their family? That seems like an expression of love too. So I think that there's a mindset of engineering, is a mindset of improvement and figuring out how to make things better, and it's mostly all set in improving things for our community, even though I think nobody's going to look at a building code and think it's an expression of love. But I mean, the intent of it is really to make sure that people are living in safe, fire-resistant dwellings.
I guess I'll take a stab at this, Jess. So, actually, to answer one of your previous questions there, my favorite invention or project of all time was the steam engine. We're taking water, we're turning it into motive power. That helped win wars, that helped industrialize, that helped breed other inventions. And perhaps it's a little bit of a dated item, right? Who sees a steam locomotive taking a train down a track nowadays, or a steam-powered tractor or a steam-powered mill? Well, we are using steam power, just in a different sense. Now we're using nuclear energy to heat water, create steam, and provide us electricity. In my opinion, anything can be designed, anything can be engineered by anyone. What you need to make that happen is determination, realism, and knowledge. And those all don't have to be contained within the same person, right? It's collaborative. Engineering itself is, by its nature, is collaborative. And to answer your question regarding love, can love be engineered? In my opinion, no, because love can't be designed. Love is something that is. Love can be materialized in certain things. It can be materialized in a building code, like Lauren said, by your local government, to ensure that its citizens receive a little love from the government by having that bit of faith that their structure is not going to fail on them, right? So to answer the larger question of can anything you dream of be designed? Absolutely, and it's up to you. And I challenge all of our listeners here today, if you have a want, that's great. If you have a need, that's nice. But none of it's possible without a solution, and that solution is right up here in your mind.
Yes, Cedric, I definitely agree with you. I think when it comes to engineering, possibilities are endless, and it's pretty much up to your limitations of your imagination. And then even then, there's many things you can't even fathom at this moment that probably will exist in the future. So pretty much it's just knowledge and gaining more knowledge to be able to engineer new things. And yeah, love it. I don't think we can make love per se. It's more showing love through material things that we can make, I guess, but not necessarily make it itself. And then it just makes me think of, like, for the future, like I said, the things that we can't even fathom yet. I remember reading when I was younger, like alternative fuel sources. They were using like vegetable oil for like cars, and now we have all electric cars. Like, you know, they weren't there at that point, like 30 years ago, but now they are. And then probably closer in the future, you know, more electric cars, and maybe even, as we thought way back when, flying cars or something crazy like that, you know? I know in the military they've even mentioned things like invisibility. Like, it kind of sounded crazy to us, but, you know, they're telling us that it's actually kind of near. So watch out there.
Well, Stacey, isn't it? Right now we're seeing in, like Jess said, in pop culture, like things from Back to the Future when we watch those movies are starting to come, you know, to fruition now. And there's other pop culture references, so maybe one day, you know, we'll see all the Avenger tools, you know, coming into light, like you said. hidden drones and stuff like that just by using optical illusions and invisibility.
Yeah, okay, I can totally see, like, the drones, like, that became a much more used thing now. That wasn't used that much before, and that's something that's been used to the advantage, at least for the military. And I can see, invisibility, drones going together. Now you can't even see the drone, all that kind of crazy stuff.
Yeah, going back to what Mary said earlier, I can imagine ordering something on Amazon, pick up your phone, order something on Amazon, and here comes the drone right through the window over here, giving you your lunch or giving you, that sack of bananas you order or something,
Like, even just picking up my phone, like, how many people had a role in this phone? And when I think about it, it's pretty incredible. Amazon, the supply chain, the logistics, every single component, it's pretty cool.
The one thing I keep thinking about is I love all the technological advances we're seeing with the phones. I would love to get droid delivery someday. But Jess, you had mentioned a question about what's our responsibility as engineers, and I hope that in the future people just remember that we should also keep the thought of being a community together. I would hate to use technology so much that we don't start talking with our neighbors still. And, I do miss seeing you guys in the office, So the human aspect and technology, I just hope, continues to be balanced so that we don't become secluded as humans. I think community is still very important in society. So.
And with that, if anyone else wants to jump on that or any final thoughts, take it away.
Can we point a question back at you, Jess?
I'll allow it.
Okay. All right. What's your take? Can anything be engineered? Can love be engineered?
I think love can be engineered, but there is something indelible about the human experience that I don't think we figured out how or if we can create it, because I think you can engineer something that looks like love, sounds like love, and for probably a brief time you can convince yourself it is love. But then after a while, it's like, I think the soul and the human experience can be like, but is it really? It questions the realness of it. Thanks, Cedric. Thanks for pointing it back at me.
No problem.
No one's ever done that before in the podcast.
There's a great amount of engineering you do in bringing all of us engineers together, right? So there's a little bit of engineering going on on your part as well, not just ours.
Oh, it's an honor to hear you say that. You are
social
also,
engineer.
Yeah, and you guys are honorary communicators, professional communicators, for being on here. So thank you so much for being here today. And that's a great transition to leading us out of the podcast. Thank you, everyone, for being on the Building Strong Buffalo podcast and sharing yourself with the world. All of you, each one of you, are wonderful engineers, creating a positive influence on society. And as members of USACE, you're part of 37,000 dedicated civilians and soldiers delivering engineering services worldwide. We're not making virtual reality or even cryptocurrency, but the core team makes our engineering world go round by strengthening our nation's security, maintaining infrastructure, and supporting our servicemen and women. We're working in engineering in a time of tremendous change, and as always, the Corps of Engineers is adapting and innovating to deliver engineering solutions for our nation's toughest challenges. If you want to learn more about the Buffalo District, check out the description for our website and social media pages. We'll be uploading new episodes of the podcast to Spotify, Apple, Anchor, and all of your favorite podcasting platforms. So check your apps. Thank you for listening, and essay ons.